Hello, Math 95 students. We are on section 12.3, which is going to be adding and subtracting rational expressions. So in 12.1, we learned how to simplify a rational expression, how to find the domain of a rational expression, and how to plug something into a rational expression. In 12.2, we learned how to multiply and divide rational expressions. So 12.3 is about how to add and subtract rational expressions. So adding and subtracting rational expressions, in other words, adding and subtracting fractions, is actually a little more difficult than multiplying and dividing. With multiplying and dividing, all you have to do is just cancel things out and then multiply straight across. But with adding and subtracting, you have to have a common denominator before you can add or subtract. Let's just look back and review some things from elementary and middle school. So let's say if we were adding 1/7 and 3/7, they already have a common denominator, 7, right? And if you eat one piece of pizza that's cut into 7, and then you eat another 3 pieces of pizza that's cut into 7, then you've eaten 4/7 of a pizza. So you just add the top. You only add the numerators. You don't add the denominators. The denominator just stays the same. Okay? But if we had something like, let's say we had 3/4 plus 1/3, then we would have to get those. You can't add them as they are. You'd have to get them to have a common denominator first. It's like trying to add inches and centimeters. They're not the same units. You got to convert them to the same units first, and before you can add them. So what we're going to do is we want them to have the same number on bottom. So you're trying to think of what's called the least common denominator, also known as the least common multiple between 3 and 4 here. So the least common multiple between 4 and 3 is like what's the least number that they can both multiply to become. So you think, the multiples of 4 are 4, 8, 12, 16, 20, and so on. The multiples of 3 are 3, 6, 9, 12, 15, 18, and so on. Well, what's the least common multiple means? What number do they have in common? The 12, right? And that's the least common multiple between them. So we would multiply, we want the 3 to become a 12, so what do? We multiply it by 4, and that makes it become a 12, but whatever we do to the bottom, we can do it as long as we do the same thing to the top, we're okay. But you got to do the same thing to the top that you do to the bottom. The reason being is because that keeps it the same value. Like basically if you multiply by 4 on top and 4 on bottom, that's 4 over 4, which is 1. So you're multiplying by 1, which doesn't change the value of anything. All right. What will we multiply the 4 by to make it become a 12? We multiply it by 3. And then I got to do the same thing to the top. So that this problem now becomes, let's see, the left one becomes 9/12, and the right one becomes 4/12. So the final answer here would be 13/12. And it's fine to leave it as an improper fraction. If you wanted to write it as 1 and 1/12, that's fine too. All right. Now that's just a review to get to how to do this with algebra, not just arithmetic. All right, so let's go to example 1 here. We got to add these two things, 4x plus 3 over x plus 2 over x. All right, since they already have a common denominator, that makes it not too difficult. They both have an x as the denominator. So we can just go ahead and add them simply by adding the numerators, which means we're going to combine like terms in the numerators that are on top of the fraction. Okay? So 4x plus 3 plus 2 means we're going to add the 3 and the 2 The 4x is just going to stay the 4x because it doesn't have any like terms to combine with, but the 3 and the 2 combine to make plus 5. So I get 4x plus 5. And on the bottom, remember the bottom does not change. It just stays like it is. So it's just 4x plus 5 over x. And that's my answer. All right. Let's look at example 2 here. Question, does it already have a common denominator? Yes, it does. When it already has a common denominator, that's good. All you got to do is just combine all your like terms on top. So x squared doesn't have any like terms, so it just stays x squared. Negative 10x combines with positive 2x because they're like terms. So negative 10x plus 2x is minus 8x. And then plus 15 doesn't have any like terms, so it just stays plus 15. And that's all over x minus 5. Okay, and that's a good answer. There's actually more that you can do here. This is a good answer, but it's not reduced. It's not put in simplest form. Like if we added our fractions back when we were doing arithmetic, if we added our fractions and we ended up with 9/12 as the answer, that's a good answer, but it's not reduced. You got to reduce it, and we'd have to reduce this by dividing both of them by 3 because that's the greatest common factor there, which would give me 3/4. Well, that's kind of what you got to do here. You got to simplify this expression like we learned how to do back in 12.1. How can we possibly simplify this expression? When there are pluses and minuses involved, when you're simplifying, you have to, the only way you can simplify is to factor. See if you can factor anything. I know I can't factor the bottom, it's already in simplest terms, but the top I can factor. How does x squared minus 8x plus 15 factor? It factors as x minus 5 and x minus 3. See, factoring just stays with you. It just, you can't get rid of it. It's all over the place in math. And that, negative 5 plus negative 3 is negative 8. Negative 5 times negative 3 is positive 15. All right, and that's over x minus 5. So now, we get to cancel out the x minus 5s. And so my final answer here is simply x minus 3. And that's my answer in simplest terms. All right, how do we add these two fractions when they don't have a common denominator? What we have to do is make them have a common denominator. We got to first look at the numbers, the 6 and the 2, and say, I want to make those numbers be the same, just like we did, I showed you earlier with the arithmetic example. So the least common multiple between 2 and 6 is 6. Right? Because, 6, 12, 18, 2, 4, 6, 8, 10, 12. 12 isn't common, but the lowest one is 6. So the 6 can stay like it is. All right? The 6 can just stay a 6 because it's already a 6. But to make the 2 a 6, I need to multiply by what? I need to multiply by 3. That's going to make the 2 become a 6. And what do I do to the top? I got to do the same thing to the top that I did to the bottom. So that's going to make the bottom of this fraction become a 6w. Still not the same though, is it? Because this one has a w on bottom, whereas this left one does not have a w on bottom. So what do I do to make this one be the same as that one? Well, I got to give that one what that one has. I got to give it a w. So I have to multiply this left fraction by w. And I do the same thing to the top that I did to the bottom. Okay, so what's that give me? This left fraction becomes w times 1, which is just w, and w times 6, which is 6w, plus 9 times 3 is 27, over 2w times 3 is 6w. And now I have a common denominator. And I can just go ahead and add these fractions by combining like terms on top. Now the terms on top are w plus 27. They're not alike, so I'm just going to write them like they are. W plus 27. They can't combine. You just got to write them beside each other like that. So w plus 27 over 6w is my answer. All right, check out example 4 right here. Same situation as the previous problem. I've got an 8 and a 12, and I'm thinking, what is the least common multiple between 8 and 12? If you can't figure it out, just start writing the multiples of 8. 8, 16, 24, 32, 40. And multiples of 12, 12, 24, 36, 48, and so on. Well, what's the least common multiple? We can already see it's 24. So what do I need to multiply the 8 by to make it become 24? I need to multiply it by 3. Because 8 times 3 is 24. And I need to do the same thing on the top that I did to the bottom. What do I need to multiply the 12 by to make it become a 24? Multiply it by 2. And I do the same thing to the top that I did to the bottom. But now also look at the variables. The x's have to also be the same. This thing has an x. The right one has an x cubed. So x cubed is x times x times x. So that means I need to give this left denominator 2 more of those x's to make it become just like the x cubed. So I need to multiply this one by x squared. Because x squared times x is going to make it become an x cubed. And I do the same thing to the top that I did to the bottom. So now this becomes, on the top left here, 2x squared times 7 is 14x squared. Over the bottom, 2x squared times 12x is 24x cubed. Plus 5 times 3 on the top right is 15. And 8x cubed times 3 is 24x cubed. So the denominators are the same as we knew they would be. So now I just combine it into a single fraction by combining any like terms that I have on top. I don't have any like terms on top, so I'm just going to write it beside each other. 14x squared plus 15 over 24x cubed. And it's now one fraction. And that's my answer. All right. I would look to see if I should always look to see when I have my answer, is there anything I can do to simplify or reduce this fraction? But there's nothing I can do here to reduce. So I'll go on to the next one. Example 5. There is a difference in this example between this one and the previous couple of examples. Again, I don't have a common denominator, but what I've got going on that's different here is that I've got pluses and minuses going on in this denominator. Okay, so that's going to be handled a little bit differently. What I'm thinking here is I've got x minus 4 here, I've got x plus 7. How can I make them be the same? The only way I can make those things be the same is to multiply them by each other. Like I'm going to multiply the x plus 7 by the x minus 4. And then I got to do the same thing to the top. And I'm going to multiply the x minus 4 times x plus 7. And I'm going to do the same thing to the top. And so now on the bottoms of these fractions, I've got the same thing. I've got x plus 7 times x minus 4 on both denominators. All right, so now I have to distribute on top here. I'm going to distribute that 2. And I'm going to get 2x plus 14 on top. On the bottom, I can distribute the x plus 7 with the x minus 4. And if I did, I would get x squared minus 4x plus 7x, that's plus 3x, minus 7 times 4, minus 28. I would get that if I did distribute on the bottom, but I don't have to. The reason I don't have to distribute on bottom is because I'm not going to be combining any like terms on bottom anyway. So I can just leave the bottom as it is, undistributed. Just leave it like that. That's what I would recommend to you. Again, if you did distribute, there's nothing wrong with that. It's just doing extra work that is not necessary. All right, plus, and then distribute here on top. We do have to distribute on top. You just don't have to distribute on bottom. We have to distribute on top because we've got to combine our like terms on top. But we don't have to distribute on bottom because we don't have to combine anything on bottom. The bottom stays as it is. So that's going to be 6x minus 24 on top there. And the bottom is x plus 7, x minus 4. Now we have a common denominator. We can just combine like terms on top. 2x plus 6x is 8x. 14 plus negative 24 is negative 10. So 8x minus 10 on bottom. X plus 7. X minus 4 on the bottom there. 8x minus 10 on top. 8x plus 7x minus 4 on the bottom. You might think to yourself, is there anything I can do to reduce this? Maybe I can factor the top. Maybe it'll reduce. So you could try. I can take out a GCF on top. The GCF there would be 2. And it leaves me with x minus 5. I'm sorry, it leaves me with 4x minus 5. But that doesn't allow anything to cancel with the bottom. Therefore, the factoring didn't help me reduce anything. So I'm just going to leave the answer as it is because there's no reducing to be done. I can't do any reducing. Okay. All right, let's look at this one. Example 6. Again, we don't have a common denominator. And again, we have a plus or a minus sign involved on the bottom. What I would do is, if I have pluses and minuses involved on the bottom, I would go ahead and factor if I can. Like the 2x minus 8 can factor. I can factor out the GCF. What's the GCF? The GCF is 2. And it leaves me with x minus 4. Okay? So now I'm looking at my denominator on the right, and I've made it into a factored expression. Okay, the reason that can help me now is because now I'm just looking at the 6 and the 2. The 6 here and the 2 there, and I'm trying to make those two become the same number. What's the least common multiple between 2 and 6? We've already looked at that earlier. It is 6. Therefore, the 6 can stay as it is. The 2, I need to multiply it by 3 to make it become a 6, and I'll do the same thing on the top. The only other thing I need to do, since this right denominator has an x minus 4 in it, then I need to also give the left denominator an x minus 4 for it to be the same. So now I'm going to distribute on top, but I'm not going to distribute on bottom. So that's going to give me 5x minus 20 when I distribute that 5 over 6 times x minus 4 plus 3 times 7 is 21 on the top of the right fraction. And on the bottom of the right fraction, I'm going to go ahead and multiply the 2 with that 3, and that becomes 6. And that's also times x minus 4. The denominators are now the same. So I can just combine my like terms on top. All right, 5x is going to stay as it is. Minus 20 combines with plus 21 to get plus 1 over 6 times x minus 4. All right, and there's no factoring to be done. There's no reducing that I can do, so that is my answer. All right, example 7. You need to try to, again, since there's pluses or minuses involved on the bottom, we need to go ahead and try to factor the bottom expressions. So go ahead and try to factor these two bottom expressions before I do it. All right, so if we factor the bottom left, I'd factor out the GCF. The GCF is 2, and it leaves me with x minus 2. Okay. If I factor the bottom right, x squared minus 4, that's a difference of squares. That will factor as x plus 2, x minus 2. Okay, that has helped me because now I can see that x minus 2 is already the same. So I'm not going to even have to worry about doing anything with x minus 2 because that's already the same. But I'm going to have to do something with that 2 and with that x plus 2. So what I'll do is, I'm saying, what does this denominator have that this one does not have? This one has a 2 right there, and this one doesn't. So I'm going to multiply it by a 2 so that it'll have that 2. Now, is there anything that this right denominator has that this left one doesn't have? This right denominator has an x plus 2 that the left denominator does not have. So I'm going to give it that x plus 2. And I need to remember what I need to remember. Whatever I do to the bottom, I've got to do to the top. So since I multiply this bottom by 2, I've got to multiply that top by 2. And since I multiply this bottom by x plus 2, I've got to multiply this top by x plus 2. It's so easy to forget to do the same thing to the top that you do to the bottom. So keep that in mind. All right, so now for this fraction, I'm going to go ahead and distribute on top. If I distribute on top, that gives me x squared plus 2x, right, when I distribute this on top. And that's over. I'm not going to distribute the bottom. I'm just going to write it as 2 times x plus 2 times x minus 2 plus, on the top of the right, negative 4 times 2 just gives me negative 8. And on the bottom, again, I've just got 2 times x plus 2 times x minus 2. Okay. Now, I've got a common denominator. All I've got to do is combine it into a single fraction and combine any like terms that I have on top. So I'm doing that. The x squared, actually I don't have any like terms on top. I'm just going to write them all beside each other. The x squared, the 2x, and the minus 8 just all get written together like that. They combine into a single expression, and then the bottom stays like that. Now, this might be my final answer, but it might not be, because it might be able to reduce. Why don't you see what can happen? See if you can figure out if it can reduce. What we would do is we would factor the top and see if the top is factorable. Then I'll factor it and see if there's anything that cancels out. So let me, need some more room. I'm going to come up here and do that. The top of that fraction factors as x plus 4, x minus 2, over 2 times x plus 2, x minus 2. Hope you see how that factors that way, because 4 times negative 2 is negative 8. 4 plus negative 2 is positive 2. All right, now what is there anything that can cancel? Yes, the x minus 2's can cancel. So my final reduced answer, in simplest terms, is x plus 4 over 2 times x plus 2. And that's my final simplified answer. Okay, beginning in example 10, we have subtracting going on instead of adding. Okay, so let's see how that affects us. So look at example 10. The good thing about example 10 is we already have a common denominator, so we don't have to do any factoring on bottom, because we already have a common denominator. So that's good. All we have to do is combine like terms on top. What you need to do, though, to deal with the subtraction, it won't matter as much in this problem, but it matters in other problems, especially when there is more than one term in the second fraction, is change the minus sign to a plus, and then distribute the negative into the top part of the second fraction. So in other words, anything in the numerator up here will change signs. So that 2 will become a negative 2. And now you can do it just like adding, just like you did when it was adding. So we just combine like terms on top. X plus negative 2, they're not like terms, so I just write them beside each other. So my answer is x minus 2 over x squared minus 4. Now this one would be our final answer, except that we can factor that. So that becomes x minus 2 over this part factors as x plus 2, x minus 2. This cancels. So when everything cancels on top, you're left with a 1 on top. See, x minus 2 over x minus 2, that's 1. So when it cancels, it doesn't just go away. It always leaves you with a 1 when things cancel. So I'm going to write this as 1. So the x minus 2 becomes a 1. See, that becomes a 1 and that becomes a 1. But this one doesn't matter that it becomes a 1 because 1 times x plus 2 on bottom just leaves you with x plus 2 on bottom. But it's important that this one here, that you leave that as a 1 on top, because it matters that you have that 1 on top. All right, let's look at example 11. All right, they already have what? They already have a common denominator, which is really nice. That means that we don't have as much work to do. All we got to do is combine our like terms on top. But because it's a minus sign, we need to change it to a plus and then change the signs of everything in the top of the second fraction. So that's going to become a negative 3x, and it's going to become a negative 28. Okay, so now combine like terms on top, and I have x squared minus 3x minus 28 over x plus 4. Okay, see if there's anything you can do to simplify that fraction before I do it. Okay, we would factor the top. The top will factor as x minus 7, x plus 4 over x plus 4. The x plus 4s will cancel, and so you're just left with x minus 7. Now you might be saying, well, I thought there was a 1 left on bottom. And you're right, there is a 1 left on bottom. But a 1 on the bottom doesn't matter, because x minus 7 over 1 is the same thing as just x minus 7. But when a 1 is left on top, it does matter. So a 1 on the bottom, you don't have to put it. But a 1 on the top, you do. All right, so this is my final simplified answer. All right, here's one where we don't have a common denominator. So I'm going to have to first get a common denominator here. So look at the numbers 4 and 2 and say, what is the least common multiple between 4 and 2? And it is 4. So the 4 can stay like it is, but what do I do to make the 2 become a 4? I multiply it by 2. Now let's look at the a's. This is an a, this is an a cubed. So the a cubed can stay like it is, but what do I need to do to the a to make it become an a cubed? I need to multiply it by what? By a squared. Right? That makes it become an a squared with times an a makes it become an a cubed. All right, this one has a b squared, this one has a b. So the b squared can stay like it is here, but this b needs to multiply by what to become a b squared? It needs to multiply by a b, because that b times that b will become a b squared. And what did I forget? I forgot that whatever you multiply on bottom, you also need to multiply on top. And that is so easy to forget. Whatever you do to the bottom, do the same thing to the top there. So let's see, that gives me, on the left side, it gives me 5a squared over 4. And then the a squared times the a makes that become a cubed b squared. And then I'm going to change that minus to a plus. So that's going to become a negative 3. So this is going to be plus negative 3 times 2b is negative 6b over 2 times 2 is 4. A cubed, and then b times b is b squared. So I have a common denominator now. So now I just combine it into one single fraction, and I get 5a squared minus 6b over 4a cubed b squared. There's no factoring or simplifications that I can do, so that's my final answer. All right, this is example 13. I don't have a common denominator. I need to factor these things. Since there are pluses and minuses here, I need to factor them before I can get a common denominator. All right, so also probably before I do anything else, let me change that minus to a plus. And so everything on top here is going to change signs. So that's just going to become a -5. Okay. Now let me factor the 2x squared minus 7x minus 4. I'm going to do that over here to the side. I got to do the AC method here where I take the 2 and I multiply it down there with the -4. So that becomes x squared minus 7x minus 8. Hopefully you remember this a little bit about how to do that. And then that factors as x and x, -8, +1. Then I have to remember to put the 2 back up under those. So this becomes x minus 4. And this one won't reduce, so the 2 has a slide in front of that x, so 2x plus 1. Okay, so I've got 3x minus 1 over x minus 4, 2x plus 1, plus -5 over. Now how does this right denominator factor? That's just going to be x minus 4, x minus 4. That one wasn't as hard to factor. Now I got to get a common denominator. Okay, so what does this one have on the left that the one on the right does not have? It has a 2x plus 1. So I'm going to give the right one a 2x plus 1. I'm going to multiply the right denominator by 2x plus 1. And remember that whatever I do to the bottom, I need to do to the top. And now what does the right denominator have that the left one doesn't? The right denominator has an extra x minus 4 that the left one does not. So I'm going to give the left one an extra x minus 4 so that they'll be the same. And I got to do the same thing to the top that I do to the bottom. And that should get me a common denominator. Okay, I got to distribute everything on top. Okay, so I got to distribute all this stuff. Okay, so that gives me 3x squared. Gives me 3x squared minus x minus 12x plus 4. So that's combine those now. That gives me 3x squared minus 13x plus 4 over x minus 4, x minus 4, 2x plus 1. Plus, distribute here as well. That's going to be -10x minus 5 over x minus 4, x minus 4, 2x plus 1. I now have a common denominator and I'm ready to combine this into one single fraction by combining the like terms on top. So that's going to be 3x squared. Doesn't have any like terms, so it just comes down as it is. The -13x combines with the -10x to get -23x, so minus 23x. And then the +4 and the -5 combine to make -1 over x minus 4, x minus 4, 2x plus 1. And there's no factoring I can do. Like if I try to do the AC method here on the top, it's good to think about it, but it won't work. It can't be factored on top. So that's my final answer. All right, example 16. I'm not doing every example. I'm skipping some. some of the tougher ones, because we're not going to do any like that. Okay, so it gives me f of x, and it gives me g of x, and it says find an equation for f minus g, which just means I have to subtract the f function and the g function. So so f minus g just means I'm going to do x minus 1 over x plus 1, which is f, minus x plus 1 over x minus 1, which is g. Okay, so now I have to subtract these two fractions, and I have to get a what? A common denominator. But remember, with minuses, probably the first thing, the best thing to do here probably first is to go ahead and change the sign to a plus, and then change all the signs in the top of the second fraction. So that's going to be a negative x, and it's going to be a negative 1. So I'm going to erase that plus and change it to a minus. All right, now let's get ourselves a common denominator. I think the only way that I can make the x plus 1 and the x minus 1 be the same is to multiply them by each other. Like, there's no factoring I can do, so I'm just going to multiply them by each other. So that's going to get multiplied by x plus 1 on top, on bottom, and on top. This is going to get multiplied by x minus 1 on bottom and on top. Okay, now I'm going to distribute everything on top. So let me do that right here. That's going to be x squared minus x plus 1. So that is x squared minus 2x plus 1 over x minus 1, x plus 1, plus, now I got to distribute this. It's going to be negative x squared minus x minus 1. So that's going to be negative x squared minus 2x minus 1 all over x minus 1, x plus 1. And now I get to combine my like terms on top. Since they have a common denominator, I'm just combining them into one fraction by combining like terms on top. So let's see, x squared plus negative x squared cancels. That's 0x squared. So there's no more x squared. Negative 2x plus negative 2x is negative 4x. 1 plus negative 1 also cancels. That's 0. So I've got negative 4x over x minus 1, x plus 1. And there's no simplification I can make there, so that is my final answer. All right, there is a second part to this problem. Let's look at it. We just did part 1, but now we got to do part 2. Find f minus g of 5. That's not too hard. Now that we found this is f minus g, that's that. So if I want to do f minus g of 5, that simply means I'm plugging 5 into the function I just found. So plug 5 into x into the answer that I just got. So negative 4 times 5 over 5 minus 1, 5 plus 1. That's going to be negative 20 on top. And on the bottom I got 5 minus 1 is 4, 5 plus 1 is 6. So that's going to be negative 20 over 24. And now reduce that by dividing them both by 4. And that gives me negative 5 over 6. And that is my final answer for the second part of that problem. All right, that is the end of section 12.3. Good luck on that assignment. I know there was a lot of material covered there. I hope you're able to process it all. Work hard on that assignment. I'll see you again in 12.5. We're skipping 12.4 and going to 12.5 next.